All right, so to go on to our extra practice in 7-4 notes, a rhombus by definition is a parallelogram with 4 congruent sides. Now, right here, like it says, for any rhombus, MNOP, decide whether the statement M to O is congruent to N to P is always or sometimes true. Draw a diagram and explain your reasoning. Well, first of all, let me draw what would look like kind of a typical rhombus where we see that sides are all the same. And what's important here is that we go around the figure MNOP in order that these were written. So sketch that rhombus on your page first, MNOP. I want to leave some room to justify and explain answers. And then draw in the diagonals. So M to O and N to P. Now those are the diagonals that they're speaking of here. So the naming of the figure is important because that they wanted us to draw the diags. Now the question here is, do you guys think those are congruent in the drawing that we have? P to N is like clearly longer than the other one. So right here it's not true. It wouldn't be true that MO is congruent to NP. But I also had shared with you guys that what other figure can we call a rhombus? If I go and draw in a square, I think the square MNOP, because a square is a rhombus. A square is a rhombus. And those, yep, and Darian's drawing those in, and he's like, all right, well, if we do it as a square, you know what? Those are going to be congruent to each other. So how would we answer this question? Is it always or sometimes true? Draw a diagram and explain your reasoning. It's not true for this one, but it's true for this one. So a square is a rhombus, so diagonals are sometimes congruent. If it's a square, the diagonals will be congruent, but all rhombuses aren't squares. All rhombuses aren't squares. That's kind of important. All squares can be considered a rhombus, but all rhombuses aren't squares. This is a lot of kind of weird, detail-y definition stuff. All rhombuses aren't squares. Now when I go on to number 2 in this whole idea about a rectangle, I'm going to do my best to draw in a rectangle, and I got to call it PQRS. And by definition, a rectangle has 4 right angles, and opposite sides are parallel and congruent. PQRS. Opposite sides are parallel and congruent. Now I'm using 2 little parallel flags here and 2 markings on the left-right side to show that those are parallel and congruent. Opposite sides are parallel and congruent. Now this one wants us to draw in angle PQS, so we're right back at needing the diagonals. Do you feel like they're congruent, Darian? Yeah. This is what they're talking about, PQS, that one, and RSQ, that one. So they want us to justify whether or not those 2 are congruent, and I guess I'm going to remind you guys of something here. I got 2 parallel lines cut by a transversal. What are those angles called? The alternate interiors, yeah. I think regardless of this, because it's going to be a rectangle with parallel sides, I think we can go on to say because sides of a rectangle are parallel, these alternate interior angles will be congruent. Will always, let's see, will always be congruent. Right? I was waiting for that too. Now, as we go on to the next part, number 3, 4, and 5, I just want to point out to you guys that the measures that they're talking about, BCA is 44, it's sitting right here. A to B across the top is 9, it's already marked. And A to E is 7. Say it again?
That makes B to C 9 too.
Sure. And they say this is a rhombus. Now, in the definition of a rhombus, we said a rhombus is a parallelogram with 4 congruent sides. So actually, like Darian's picking up like AB is 9, he said DC is 9. Well, since this is we're told it's a rhombus, those are all 9. Since we're told it's a rhombus, those are all 9. And I think, too, we have a rhombus. What was the rhombus? Let me look back about rhombus diagonals theorem. Rhombus opposite angles theorem. Rectangles diagonals theorem. Let's see. So if we've got, okay, so B to C, I marked that. That's 9. You guys cool with that? How long is A to C? Right, because diagonals intersect at the midpoint of each side. So this is A to C is 7 plus 7, so that one's 14. And then the whole idea of, let's see, measure of angle ADC. Now this is interesting. Measure of angle ADC. If this guy is 44 degrees, what other measures do we have here? Do they have to be, it's a rhombus. Do we know anything about the rhombus's angles? Let's see. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Rhombus, diags, it's opposite angles. So actually, what I know is, I dropped that one there because of alternate interiors, but these would be 44 as well. Could we figure out these measures for these other sides? Like, we should be able to. What is the sum of all the angles in a quadrilateral, a four-sided figure? It's 360. So if we go on our calculator and we take away our 360 minus 44, minus 44, minus 44, minus 44, I got 184 left to split between these two other angles. Which one did they want? ADC? If I've got 184 degrees to split between these two angles, that means that this whole thing must be 92 and this whole thing must be 92. You know, so the sum of the angles comes up, and then just subtracting away the things that I know, seeing what was left, and they wanted this angle ADC, so that one's sitting at 92 degrees. So we're building on stuff that we've already done. Now we're back to, what do the angles look like? How do they compare? Let's take a look at what we've got in 6 through 8. It's a rectangle. All right, so I've got a rectangle. Given that, let's see. There's a measure they don't have drawn on here. I'm going to move my 9. It's just too close to that drawing. So they said HFG is 31. You know what? That's 31. And it's a rectangle. Ooh, what do the measures of every corner in a rectangle add to? 90. Let me see what these other sides are, just in case we need them. 90 minus 31. That means this angle is going to be sitting at 59, and this one's going to be sitting at 59. These guys are 80. We'll see what happens, what we need. EFH. Ooh, I just found an answer. EFH. They wanted that. You know, looking at the angles, I had drawn that in, and then I just looked right to the left, and that's an angle they want. Let's see, E to G. they tell me that E to G is 17 all the way through. This whole thing is 17. If the whole thing's 17, 17 split in half means I'm going to have 8.5 and 8.5 right there. I'm not sure what they're asking me for yet, but we'll see. They want H to F. They want this one. What would that one be if this whole thing is 17? A parallelogram is a rectangle if and only if its diagonals are congruent. So if this diagonal is 17, that diagonal is 17. And then what's angle FGH? Ooh, that's a nice little corner of this rectangle. It says what? FHG. Oh, FHG. We have that one too. That one's going to be 59. So like pulling apart, I didn't even do them in order. Just pulling apart the things that were given, seeing where else it fits on the drawing, and then just building from there. Bless you. Bless you. All right, now, last but not least, diagonals of a square. We read something about diagonals of a square. Maybe not. Let's see. Diagonals are congruent in a rectangle, and a square is a rectangle. Diagonals of the square intersect at K. Diagonals in a rectangle are congruent. If that one's a half, that one's a half, that one's a half, that one's a half. There you go. And they don't tell me anything about measure. Well, here's my first answer. P to K is a half. P to K is a half. They don't give me anything about measure, but this is a square. So I know that every corner is 90 degrees in a square. Every corner is 90 degrees. And I also believe, let's see what I got. Each diagonal bisects a pair of opposite angles. A square is a rhombus because a rhombus's definition says it's a parallelogram with 4 congruent sides. So that means then for this square, if each corner is 90 degrees and it's been bisected, all of these little angle measures here are going to be half a 90. They're all 45. I don't know if I need to write them all in, but just for note taking today, we might as well. Splitting 90 in half gives me 45. And then let's look at what they actually want the answers to. Angle PKN. Ooh, that's interesting. If these two corners are 45, I just shaded a triangle here. A triangle's sum is 180. If I take away 45 twice from 180, that measure tells me that that one's going to be 90 degrees. I feel like there's a theorem on that one too. And then they want MNK, and we had actually marked that one at 45 degrees.